Okay, so here we see another integral that we can attack with trig substitution. So the 1 minus x squared gives us a hint that we should be using sine theta for the substitution. So let's see how it goes. So if we let x equal sine theta, then we can build out the rest of the integral. So that means dx equals cosine theta d theta. And then 1 minus x squared will also be cosine theta. So now we can substitute it into the integral. So this is going to be equal to the integral of cosine theta d theta in the numerator. And then we have 1 minus x squared to the 3 halves. So sorry, I forgot a cosine squared here. So that's going to give us cosine cubed theta in the denominator. Okay, so now this can cancel, and that leaves us with the integral of 1 over cosine squared theta d theta, which is the integral of secant squared theta d theta. And then if you remember, this is the antiderivative, or this is the derivative of a basic function. So the derivative of tangent is secant squared, which tells us the antiderivative of secant squared is tangent. So that means we have tangent theta plus a constant of integration. But now we need to put it back in terms of the original variables. So we'll draw a triangle, label this side theta. And if we have x equals sine theta, we can rewrite that as x over 1 equals sine theta. Then using the fact that sine is opposite over hypotenuse, so that means we can label the opposite side with x, the hypotenuse with 1, and that gives the adjacent side as 1 minus x squared all into the square root. That allows us to find tangent very easily. So tangent will be x over 1 minus x squared. So that gives us x over the square root of 1 minus x squared plus a constant. And that's our final answer.